Let's find the general solution of this given differential equation, that is y double prime plus 6y prime plus 9y equals 0. So basically this is a second order differential, homogeneous differential equation. So let's see how to find this general solution. The first thing to do is we have to find the characteristic equation. So let me write the characteristic equation for this differential equation. So we can write down this, replace this y double prime by r squared plus 6 times of y prime is replaced as r plus 9 times of y is replaced as just 1. So it becomes 9 and this equals 0. So basically this is the characteristic equation for this given differential equation. Now we have to solve this characteristic equation to determine the roots of this equation. So basically we have to find the value of r, which makes this characteristic equation becoming 0. So either we can utilize the factorization method or we can utilize the formula, that is a quadratic formula. I'm going to use the factorization method. So I can rewrite this left side expression, that is r squared plus 6r plus 9, as a product of two linear terms, that is r plus 3 times of r plus 3 equals 0. Now we'll solve this roots. So either r plus 3 equals 0, that is one of this term is 0. Also the other term is 0, that is r plus 3 equal to 0. So basically we are going to get two equal roots, that is r equal to negative 3 over here, and here also if we solve for r we get r equals negative 3. So basically the roots of this characteristic equation is negative 3, which appears twice. So in this case we can write down the general solution of this type of characteristic roots as y of t. Since t is the independent variable, I write down this as y of t, or sometimes we can just replace this as simply as y. So y equals y of t, and this equals a e power r t plus b times of t e raised to the power of rt. We will now replace the value of r, which we have just found. So therefore, the general solution is y equals a times e power rt. R is negative 3. So this is e power negative 3t plus b times of t, that is bt, e raised to the power of once again rt, that is negative 3t. So this is the general solution of the given differential equation. We will now see how to determine the particular solution of this given differential equation. So for this, we can utilize the general solution as well as the given initial conditions. So I'm going to rewrite this general solution as a function of t. So I'm going to write down this y as y of t, and this equals a e raised to the power of negative 3t plus b times of t e raised to the power of negative 3t. So this is the general solution of the differential equation. And first, I'm going to use this initial condition, that is y of 0 equals 9. And this means at t equal to 0, y of 0 equals 9. So first, let me replace t equal to 0 in this general solution. So therefore, this becomes y0, that is y of 0 equals 8 times of e raised to the power of minus 3 times of 0 plus b times of t is replaced as 0. So this becomes 0, e raised to the power of negative 3 times of 0. Clearly, this second term becomes 0 because b times of 0 is 0, and this becomes 0. And we have the first term, that is a times of e raised to the power of negative 3 times of 0 is 0. So e power 0 is 1. So basically, this becomes a times of 1, which equals a. And on the left side we have y of 0, which is given as 9. So therefore 9 equals a, or we see that the value of a equals 9. So we found the value of one of the constant, that is a equals 9. Now let's see how to determine the other constant b using this second initial condition, that is y prime of 0 is given as negative 23. Since we are given this y prime of 0, Basically, we have to find the derivative of this function y of t. That is a general solution equation. So I'm going to differentiate both sides with respect to time. So when I do that, differentiation of y of t with respect to time is y prime of t, which is the derivative of y of t. And I have to find the derivative of each of the terms. So here in the first term, a is a constant. So we can put this a as it is, and then find the derivative of e raised to the power of negative 3t. So here we have to apply the power rule as well as the chain rule. So when I apply this exponential rule, I'm sorry, we will not have to apply the power rule. We just have to write down the formula for the derivative of e power x. So derivative of e power x, this is basically e power x only. So we will use this formula, that is derivative of e raised to the power of negative 3t is e raised to the power of negative 3t. And when we apply the chain rule to differentiate negative 3t with respect to time, we get negative 3. So I put this as a product negative 3. Now we will find the derivative of the second expression, that is bt e raised to the power of negative 3t. And so here we have this constant b, and now we have to consider this expression t times of e raised to the power of negative 3t as a product, and we have to use the product rule. So let me put, we have b, and then I put a square bracket since I'm going to find the derivative use the product rule. So I consider the first term, that is t, as the first term, and the second term e raised to the power of minus 3t. So when we apply the product rule, we have to find the derivative of the first, which is the derivative of t, which equals 1 times of the second term, that is e raised to the power of negative 3t, plus we put the first term as it is and find the derivative of e raised to the power of negative 3t. We already found it in the first part, that is, it is basically e raised to the power of negative 3t times of negative 3 when we apply the chain rule. So let's close this bracket. Now let's get this simplified. So we have y prime of t, and this equals a times of negative 3 is negative 3a, and then I put e raised to the power of negative 3t plus b times of 1 times of e power negative 3t is negative e raised to the power of negative 3t, and here we have negative 3. So t times of negative 3 is negative 3t e raised to the power of negative 3t. So we found the expression for the derivative of the y of t, that is y prime of t is the derivative of the function y of t. Now we are going to use this second initial condition, that is y prime of 0 equals negative 3. This means at t equal to 0, y prime of 0 equals negative 23. So let's replace all the t by 0, and when we do that, we will get y prime of 0. This equals negative 3a e raised to the power of negative 3 times of 0 plus b times of e raised to the power of negative 3 times of 0 minus 3 times of t is replaced as 0. So this becomes negative 3 times of 0 e raised to the power of negative 3 times of 0. So we closed it. Now we can clearly see that this term becomes 0 because 3 times of 0 is 0. So let me simplify this. This is y prime of 0 equals negative 3a, and we know the value of e raised to the power of negative 3 times of 0, which is e raised to the power of 0. So basically this value is 1 plus b times of, we have only one term, that is once again e raised to the power of negative 3 times of 0. This is again 1, so this becomes b times of 1, which is simply b. So I just put it as b. Now I'm going to replace this value y prime of 0 equals negative 23. So I replace y prime of 0 as negative 23 in this equation. So this becomes negative 23 equals negative 3 times of, we will also replace the value of a, which we also already found out, that is a equals 9. So this becomes negative 3 times of 9 plus b. So we can now determine this value of b when we add 27 to both sides. So this becomes negative 23 plus this is negative 27. So that's why we add positive 27. So this becomes b equals 4. So we found the value of b, which is equal to 4. And we also determine the value of a, which equals 9. So using those two values, we will have to substitute into the general solution so that we get the particular solution. So I'm going to copy the general solution and then substitute the values of a and b. So we have the general solution as y of t. This equals a times of e raised to the power of negative 3t plus b t e raised to the power of negative 3t. So we will replace a equals 9 and b equals 4 in this general solution. Therefore, this becomes y of t equals 9 times of e raised to the power of negative 3t plus b is 4. So this becomes 4 times of t e raised to the power of negative 3t. We now see that we have the common factor e raised to the power of negative 3t in both terms. So we can factor this. So finally, we write down this particular solution, that is y of t. Sometimes we can replace this as y as well. So we can write down either as y of t or y. And this equals, when we factor the e raised to the power of negative 3t, we get 9 in the first term and 4t in the second term. So this is the expression, or else we can also write down this as other form as 9 plus 4t times of e raised to the power of negative 3t. So this is either we will use y of t, and this is the particular solution of the given differential equation.